Okay, so now I want to talk to you about a term that we call dimensional analysis. And really another term for this would just be unit conversion. And dimensional analysis or unit conversion is really just a fancy way to change from one unit into another. Let's start with something simple. So let's say that we have a measurement of energy, and that energy gives us 7 gigajoules. GJ for gigajoules. And we want to change this to joules. So it's going to equal some number of joules. And this sort of thing is pretty easy to do because if you look up on your reference table, G, you can see, stands for an order of magnitude 10 to the 9th, meaning 7 billion joules. So you could just simply write this as 7 times 10 to the 9th joules. That's pretty easy for most people to do, but it's very often the case where people want to change from centimeters to meters, where they might go the wrong direction and they multiply instead of divide. And whether you multiply or divide depends on whether you're getting bigger or smaller. So that's where this term dimensional analysis comes in. So let's say instead of this, we want to change it into some number of electron volts, because electron volts is another unit of energy. And so what we'll do is we'll start with our base unit, 7 times 10 to the 9th joules. And we want to put something into the parentheses here that is going to change the units and get rid of that joules and change it into electron volts. And so keep in mind that whenever we multiply a number by the number 1, you get the same number. So 7 times 1 is equal to 7. So in theory, if we multiply this original quantity by a ratio where the top equals the bottom, if you have something where the top equals the bottom, you divide one number by an equivalent number, this ratio here is equal to the number 1 if the top equals the bottom. The difference is, if you put the units in correctly, you should get the joules canceling out, and then you're left with only electron volts. So the question then becomes, what do we put into this equation? So if we look on the first page of the reference table, we can see here on the bottom, 1 electron volt equals 1.6 times 10 to the negative 19th joules. So let's think about this. 1 electron volt equals 1.6 times 10 to the negative 19th joules. And so all you're doing at this point is you are multiplying and dividing. 7 times 10 to the 9th joules times 1 electron volt divided by 1.6 times 10 to the negative 19th joules. The top equals the bottom. We're just multiplying this number by the number 1. So we're not changing the measurement, we're just changing the units. You'll notice the joules here cancels the joules there. 1 just goes away when you multiply it. So you're left with 7 times 10 to the 9th multiplied by an EV divided by 1.6 times 10 to the negative 19th. That's all that's left. So then you can put this into your calculator, which I didn't bring with me. But let me get one. You can do that right now while I'm walking. Calculator science. I'm going to just say 7 times 10 to the 9th divided by 1.6 times 10 to the negative 19th. And I get an answer of 4.3 times 10 to the 28th. And your units, the only units that's left, are electron volts. Now let's say you do this the wrong way. You should figure that out pretty quickly. Let's say, for example, you want to change something like 7 centimeters into meters. You know that you need to put a ratio here where the top gets you the unit you want, meters, and the bottom gets you the unit you want to get rid of, centimeters. because when you multiply centimeters by a fraction where it's 1 over centimeters, then those centimeters will get canceled out. And you know that 1 meter equals 100 centimeters. But let's say, for example, you make a mistake and you put it like this: 1 meter equals 100 centimeters. This is correct. This right here is a fraction or a ratio where the top equals the bottom. 1 meter equals 100 centimeters. So if you did this, 7 centimeters times 100 centimeters divided by a meter, and you pay attention to the units, you'll realize that what you end up getting is 700 cm squared divided by a meter. So even though this is technically the correct answer, it's not the correct unit. And the fact that your units don't cancel each other out is a sign that there's a problem. But now you know that 7 centimeters is equal to 700 centimeters squared per meter. Let's fix this, of course, and say meters, centimeters. 1 meter equals 100 centimeters. So now when we do this, you end up canceling those out. 7 times 1 is 7. You end up with meters. It's divided by 100. So you end up getting 0.07 meters, which is 7 times 10 is negative 2 meters. You can do this with any sort of unit when you're changing from one unit to another. The technique is called dimensional analysis. We're going to use it throughout the year. Thank you.